Very good morning. Thank you so much for joining us today for a very special masterclass on applying AI and IoT to keeping your workers safe in a COVID world. As we all know, that because of the COVID pandemic, all over which has affected almost all countries all over the world, it has created because of the social distancing norms and a lot of other complications, difficulty in working. And at the same time, it has created an opportunity for technology to step in and drive development and productivity. Today, we have the Master of Masters to come here and teach us about how we can apply AI and IoT in keeping your workers safe and how you can drive your productivity. Let me introduce to you Mr. TEJPREET S. Chopra, who is the former CEO of GE in India, Sri Lanka, and Bangladesh. After 15 years at GE, he has founded the Bharat Light Company, which is involved in clean power generation, and they build and operate their solar and hydro farms. He also has an independent tech company called AI India, Industry AI, focused on AI and IoT solutions. He is also a young global leader at the World Economic Forum and also an Aspen Fellow. Sir, I welcome you, and now I request you to please take over and start the session. Thank you.
Great. Thanks so much, Shreya, for the introduction. Really appreciate having me on the Aspen Institute platform. I'm excited to be out here and happy to share what we've been doing, especially over the last 12 weeks, to really drive workforce safety across India and all over the world. So I'm just going to put on a few slides right now to walk you through. So Shreya, can you see my slides right now?
Yes, sir, I can.
Perfect. So a quick background in terms of who we are and what we do. One of the independent companies within the BLP group is a technology platform called Industry.ai. And Industry.ai is really an enterprise in AI and IoT company that's really driving digital transformation in manufacturing all over the world. What I want to focus on today is really three things. The first one is a little bit about just the basics in terms of what we do. What is enterprise AI, what is IoT, and how it's actually used. The number two is what I want to talk a little bit about is the here and now in terms of what we're doing with regards to Corona and how we actually applying these technologies in this Corona world. And number three is just give a few samples or use cases and studies of some of these applications in the real world. So I'll just quickly walk you through a little bit of a story of why and how we created this platform. Our core business share, like you just mentioned, is actually to produce clean energy. So we were investing large sums of money in building, owning, and operating wind and solar farms. But what I soon realized was that it's the failure of the smallest component in a wind turbine that actually shuts down a $3 million machine. And that kept happening until one day one of my turbines burned down to ashes. So I went to all my suppliers, all the large companies in the world who make all these wind turbines, and I said, this just doesn't sound right, that you're doing the maintenance on my turbine, but when things fail, I'm the one who actually suffers. So that's when I started thinking about that we need to do something differently. So that's when we created this industrial digital platform. It's called Orion. And we started collecting all the data from all our wind farms and solar farms from all over India onto our platform. And given the fact that at GE we used to make these turbines, we started writing algorithms to predict failures in these machines. And over time, we became very good to be able to predict hundreds of hours before a turbine shut down, whether there was going to be a failure in a generator, a gearbox, a bearing, or a blade. And as a result of that, we were able to improve machine availability of our turbines. And as a result of that, improve return on equity on the investments we were making. So that's how this journey started. And over time, we now focus on three things. Number one, how do we use AI and IoT to drive productivity and reliability? Now, that word is a very broad word, and that will vary from industry to industry in terms of what you mean, whether it's in terms of machine availability in, say, an oil and gas company, or whether it is in terms of predictive maintenance in the auto industry. Number two is how do we drive down costs and energy efficiency? There's a huge push around the world in driving sustainability. And the third one is quality and safety are the three key parameters in terms of what we focus on. So this is how the story journey started. We started doing it for our own wind turbines and solar farms, predicting all these failures from our control center in Bangalore. And then a lot of the large utilities around the world came to us and said, listen, why don't you help us out as well? So as a result of that, we connected hundreds and thousands of wind turbines and solar farms all over the world, in France, Germany, Spain, Italy, Portugal, started getting all that data onto our platform. And then from our control center in Bangalore, predicting failures on these machines all over the world. So that's how that journey started. And then over time, we started doing projects in ports. So our team actually climbed 120 meters up on those large cranes you see on a port. They go inside those key cranes, put sensors and gateways into the trolley on the hoist, get the data out, and therefore we're able to improve throughput of things in a port by reducing the number of times the crane might fail. We work with some of the large oil and gas companies in the world to actually use AI to drive productivity and efficiency in terms of some of their manufacturing processes and some of the chemicals that they make. On the manufacturing side, we actually digitize production lines. So our IoT team actually goes on a production line, puts little sensors and gateways on the production line in order to be able to get the data out, to be able to track how these machines are performing or when it's going to fail. On the other side, we also work with a number of FMCG companies. I didn't realize how complicated it is to actually make soaps and shampoos and the kind of processes that go into just making something as simple as that. Because what we very quickly found was, even by controlling the moisture content that goes into a certain process in terms of making soap, can have a huge impact in terms of the quality that actually comes out. And then in steel factories, we actually work in terms of driving down energy efficiency in blast furnace and smelting plants by using all these AI tools. So what we really focus on in terms of AI applications are 5 core areas. And what I'd like to do is give you a little bit of a feel in this presentation in terms of how we do it and what we actually do. The first one is asset health and machine performance. One of the biggest challenges for companies around the world is to figure out how do we actually reduce the downtime of machines, improve uptime in order to improve the returns that we get in operating these assets around the world. So as a result, what we've been able to do is connect wind turbines and solar farms or any kind of a turbine anywhere in the world, get the data onto our platform, and using AI, we're predicting failures in these machines. Number 2 is supply chain optimization. It doesn't matter whether it's a truck, a train, a ship, or a container. We actually have the ability to connect these machines, get the data out, and predict failures. In terms of railway wagons, in some cases, actually a little more difficult, because what we need to do is actually put sensors into the railway wagon. But the problem in the railway wagon is there's no power source. So what we've had to do is adapt the IoT devices to actually work on rechargeable batteries in order to get the data out. In terms of energy efficiency, I think that's becoming a really big focus, given the fact that there's a lot of pressure in terms of reducing the carbon footprint around the world, reducing and driving towards net zero emissions. And therefore, a lot of people around the world are driving and creating a concept of healthy buildings. And especially now in a Corona time where people are getting more frugal and are trying to drive down costs in every little way, we are focusing a lot in creating the algorithms to drive down energy efficiency in buildings. I talked to you a little bit about what we do on ports. On asset tracking is a fascinating new world in terms of AI and IoT. What we have the ability to do is to put a screwdriver in a 20-acre factory and find it within 30 to 50 centimeters. And that's something fascinating because we do that by putting a little tag the size of a button on a shirt. These little tags have long battery lives and sub-second latency. So as a result, what would take about 10 minutes to find a box in a large warehouse, today we can find it in milliseconds. And that helps us a lot in driving asset productivity and workforce productivity in a large factory or in a large warehouse. And lastly, in terms of visual analytics, today we have the ability to change any camera anywhere in the world and make a dumb camera smart. So what we're doing is changing cameras to think like the human brain, to be able to detect defects in machines, or even detect, from a security and safety angle, to detect what's actually happening. So we actually do that through six core areas. The first one is industrial data science. So we have a huge team of data scientists that just focus on industrial coming up with algorithms for industrial science, data science. And we actually take all these data to develop these algorithms, which actually helps us predict these failures in machines. Two, a huge focus on IoT and digitization. This is the team that actually goes on factory floors or climbs up 100 meters up on a crane, or actually go on turbines to put the right sensor and gateways into these machines to get the data out. Then we have big data management, because once you get the data out, you've got to manage all this data. Track and trace is, like I mentioned, doesn't matter whether it's a truck, a ship, or a train, anywhere in the world, we can actually get the data out and track where it is and what the maintenance condition is. Visual analytics, I'll show you a few use cases on how by just looking through cameras, we can detect whether the person's safe, not safe, is he wearing PPE or not. And lastly, we do the next generation of R&D is to focus on doing analytics and algorithms on electrical signals rather than just normal SCADA PLCs that you get. So the vision really from a technology perspective is three things. The first one is connectivity. And what's been fascinating is the fact that over the last few years, the ability to connect machines and get the data out from any corner of the world has become virtually free. So therefore, the ability to make devices talk to each other, sensors talk to each other, has become much easier. Once we get all that data, the question is, what do you do with it? And that's where deep learning and AI algorithms come in, is to take all this data to start driving the efficiencies. And the last one is automation. How do you take all this and make it easier for all of us to drive productivity in a factory floor or in terms of manufacturing? So this is in one slide what we actually do. And hopefully this explains how this whole process works. Now, we don't make these IoT devices, but we get them from a number of large corporations in the world, like Cisco, Intel, Schneider, ABB, GE, Siemens. But we also work with a lot of small little startups in Finland, Bangalore, Israel, Germany, the US, that actually have these very specialized sensors that go into these machines in order to be able to get the data out. We then have a thing called our own proprietary edge software. One of the biggest challenges in the world of Industry 4.0 is that there's no standardization in IoT protocols. And therefore, what our edge software is able to do is to talk to any of these protocols in order to extract the data, cleanse the data, and push the data onto our industrial digital platform. And this industrial digital platform is called Orion. And that's where all our algorithms sit. It analyzes this data and then pushes the insights to our customers on the application. And the application could be whether we're trying to improve the productivity of a factory, of a ship, or of a wind turbine. That's what we do. So all the way from installing these little sensors, all the way through to providing insights is really what we do. Let me just make it, let me explain it to you a little bit of a different way. In every machine that exists on a factory, you generally have what they call SCADA systems or PLC systems. So when you buy a machine, you have a small little TV screen or little computer that collects all the data from the machines. While we collect all that data of the machines, the challenge is that the operator of that machine only is operating that particular machine. Whereas, how do you make sure that the plant manager understands in one comprehensive view what's happening across the production line? So what we've been able to do is to make all these individual PLCs or SCADAs of each individual machine talk to each other, get all that data out so that you're able to get all that data in one place in order to do the analytics for the insights. So what you're able to do is reduce the number of people and actually drive productivity going forward. Now, what are these sensors? These sensors look something like this. They could be small little tags, like that little black little dot that the person is holding, all the way through to very, very sophisticated sensors to measure things like temperature, pressure, vibration, oil pressure. So what you're doing is collecting all these parameters. In some cases could be 50, 100 parameters a minute. We're getting all that data on the platform, and these algorithms actually take all that data together and start analyzing all this data in order to get an insights. And like I mentioned to you a few minutes ago, the next generation of this collection of this data through IoT sensors is to be able to read electrical signals. And like I said, on a normal SCADA, we might get 20, 30, 40, 50 tags, but on electrical signals, we are able to get 5,000 tags a minute, and therefore our ability to predict failures have gone up 10x compared to what we do in the past. So basically, what are these AI algorithms? Now, just to develop one of these algorithms can take as little as 3 months, but it could also take as long as 1 year. And because it's really complicated to get all that data, to be able to bring all this together, to create an algorithm through machine learning to make it productionized. So what do they really do in a broad sense? What are these algorithms? The first one is failure prediction, which is how do you get data, live data coming from a machine, historical data, future data, bring it all together, create these patterns to be able to predict these failures in a machine well before it actually shuts down. And like I mentioned to you, what we did on the wind turbines, that's what we do. 2 is anomaly detection. Can you detect failures in certain components in a certain machine rather than just the entire machine goes down? If you can detect even component failures, that makes it far better to extend the life of the asset. We provide recommendations, but in some machines, it's very interesting. We actually create a dynamic threshold because the tolerances or aspects change based on environmental conditions that happen. So for example, in a wind turbine, as the wind speeds slow down or they go up, or different parameters in terms of wake effect happens, therefore the algorithms adjust dynamically to create a dynamic threshold. We can do asset health prediction, asset health diagnostics. So in a certain wind farm or a certain factory, why is it that 2 machines produce more energy than the other 10? Why does this one elevator fail more often than the other 10? Or why does this component in an air conditioner fail versus others? So those are some of the ways that AI is brought into the manufacturing process to drive productivity. But when we look across industries, what we've tried to do is to actually see what is a certain heat map in terms of every industry that exists. What we found is certain algorithms fit better with certain industries than in some other industries. So this is just our own personal experience of the kind of tools and the kind of algorithms that align themselves better with some industries based on what the usage is. So that gives us the ability to shrink the time to develop these algorithms based on which industry we're working with. So this is an example of some of the machine learning algorithms and computer vision algorithms that we use. So now coming to the here and now, and what do we do with all this, and what did we do since the middle of April when COVID hit us and we were all shut down? A couple of large corporations came to us and said, listen, TP, we need to do 3 things. One, if employees and workers will always remember what management and CEOs do to keep them safe in a time of crisis. Number 2, how do we prevent lost production? Because it's getting very difficult for companies to plan their production on a daily basis because they don't know who's going to be able to come to work, who's going to get sick. So how do you prevent lost production? And the third point is, how do you ensure business continuity? So over the last 12, 13 weeks, a few of us companies have come together to think about how do we take practical online experience that these challenges these companies were facing and use our portfolio suite of technologies to adapt them to come up with 3 technologies, and I'll quickly walk you through them. The first one is called Trust AI, and the second one is called Spot AI, and the third one is called UsPro. But what we figured was there were 6 key elements that we need to focus on. The first one is social distancing. The second one is mask. The third one is temperature tracking. The fourth one is a declaration. Declaration could be central government, state government, it could be the own company's declaration. And these could be things like, are you living in a containment zone? Is any member of your family unwell? The fifth one is contact tracing. The sixth one is an audit trail. So I'll quickly give you an overview of these 3 technologies in use now across companies in India and all over the world. The first one, Trust AI. Prior to Corona hitting us, what we were able to do was connect any camera anywhere in the world. You need no new investment, no new CapEx. we were able to connect any camera anywhere in the world, get all that camera feed, and using computer vision model, send out alerts when people were not wearing helmets and safety jackets. That's what we were able to do prior to Corona. What we've been able to do now is to train our computer vision models to detect social distancing and immediately send out an alert when social distancing is breached. Now, the reason why this is very difficult is because these cameras were installed 5 years, 10 years ago, and they were installed at very high, about 30, 40 meters high. And they were actually installed for security reasons, not really for social distancing. As a result, what we had to do was use neural network models and mathematical models to be able to calculate these social distancing breaches and send out alerts. And over the last 12 weeks, given the fact that we've all been locked up at home and we haven't been able to step out, we've been able to connect all these cameras in a variety of auto industry factories, airports, in a variety of industries in India and all over the world, sitting at home. So what do we really do? We take any camera, like I said, we don't need any new investment, any existing camera or any thermal camera, we connect it to the edge box. That's where the brains are. That's where our algorithms sit. It very, very quickly analyzes the feed, sends out an alert if a breach occurs through the cloud. And at the back end, your health officer or safety officer has the back end AI application into which these alerts keep getting logged. Therefore, what the health officer is able to do is to see, are there any repeat offenders? Where are the hotspots being created on a factory? How is the flow of people happening on a factory floor? And therefore, one's able to move things around to improve the way things happen. Let me just show you a live case and a live feed of a cement factory. As you can see from this video feed, hopefully everybody can see it clearly. You can see people out there wearing helmets and safety jackets showing up in green. When the camera turns in a few seconds to the other side, you'll see a lot of people walking around that show up in white. And the reason they show up in white is they're not wearing their helmets. That immediately it sends out an alert to the safety officer and he's able to take some action. The other thing we've been able to see is rather than have 20 security guards stare at 60 TV screens 24 hours a day to capture one alert, now what we're able to do is just have a few security guards in the control center because the computer vision models are able to do what a large number of security guards do, looking at TV screens. This is at one of the auto factories in India, and because of the lockdown, there weren't too many people walking around. But post that, we have hundreds of hours of camera feed showing these alerts that go out. So what these computer vision models does is using AI, they find these markers at the far end, and based on the markers, it calculates the distance and immediately sends out an alert to the health officer or the safety officer. And therefore, we are able to make it far more productive for people to really drive out these alerts and keep the people safe. This is another one of the large factories in India where they wanted to detect mask detection. So you can see out here people walking in with masks. What we're able to see is that in a large factory where people are wearing masks at the entrance, when they actually go into the factory floor, then they don't actually, they take off their masks. And therefore now we can immediately send out an alert if people are not wearing a mask. One of the big points that we've learned is that it's not only about a technology issue, but it's also an HR issue, a cultural issue, and an implementation issue. Because it's critical that companies and corporates actually make sure that we communicate the right way to staff, that it's not about policing, but it's about keeping them safe and everybody safe within the factory environment. But what's been fascinating is that in the last 12 weeks, as people see the power of these computer vision models, is that the use cases have gone through the roof. For example, in terms of automation, in terms of quality, if one can track now quality defects on a manufacturing floor far better than the human eye can see. So one's able to actually automate these by sending out alerts using these computer vision models. Safety, on a construction site with 20,000 people, can we actually see whether people are wearing safety harnesses? Are they wearing the actual safety glasses? So therefore, the use cases have gone up there. Security, we talked about, rather than having 135 people at a factory, security guards, can we bring it down to 20 and have these cameras detect all these alerts when things are breached. On a port, can we detect speeding trucks on a port? So therefore, the use cases using these computer vision models have increased dramatically. Let me just give you a quick flavor of some of the examples that we're thinking about and testing right now. One is on a moving train. We can actually use these computer vision models to detect, is there a dampener plate missing? Is there a bolt missing? And actually detect failures like this using these computer vision models. This is for geofencing. You will see in this video that the black square out there is a notional black square. And if we were testing and training our models, and this is just an R&D picture, so that now we can send out an alert if we don't want people coming into that black square, or if that's what you want to geofence, we can actually create that geofencing and send out alerts every time somebody comes into that particular area. So I just wanted to give you a feel of the power of computer vision models as we go along in a post-COVID period as well. Coming to the second technology. The second technology is called Aspen. Some of the large corporates in India who have 30, 40,000 people wanted a really quick, easy, low-cost solution to roll out. They didn't want to make much CapEx, and they wanted to actually implement it very easily, very quickly to keep people on the factory floor safe. So we came up with a second technology, and that's called Aspen. In short, what we do in this technology is that we've figured out a way to make two cell phones communicate with each other. So it doesn't matter whether it's a Huawei, Oppo, Samsung, iPhone. When two phones come within a certain distance, it actually sends out a loud sound. So it's really an active defense system for corporates rather than a passive defense system. And once again, the idea out here is it's really to change human behavior rather than anything else. The downside of this technology is that the accuracy is not very precise, given the fact that in this situation, you're relying on the hardware protocols of the phone itself. One of the critical parameters for a lot of large multinationals was privacy concerns. And therefore, we've taken many steps to ensure that the technology only works within the four walls of the factory floor or within the four walls of the office, and we don't use this technology outside that for privacy concerns. As a result of that, what employees just have to do is put their name and their ID card. And what you can see out here is when two people come within the 2-meter distance, immediately it turns to red and sends out a loud sound. On the other hand, what we can also do is we create a risk score based on the company's questionnaire that they have. Based on the answer that the employee gives, it changes the risk score to a high or a low. But one of the critical points that all these large corporations wanted was to create an early warning system in order to keep the 40,000 people safe. So what we're doing right now is to measure the temperature of 40,000 people every 3 hours. So that temperature gets logged in, taken, and it gets logged into the backend AI application. The way we measure this temperature is a number of ways. We have some really low-cost ways to really fairly expensive ways. One of the more sophisticated, a little more expensive ways is to have this iPad-looking tablet where you can just put your face out there. It recognizes your face and your mask, and also has an inbuilt temperature scanner which measures the temperature on your forehead and logs it into the system, all the way through to fairly low-cost ways where you have a small little thermal scanner that you can put on the wall where the workforce can go there, put their forehead there, and in a second, it keeps recording it into the application. As you can see out here, for privacy concerns, even if both of us work in the same company, I end up as an encrypted code on your phone, and you end up as an encrypted code on my phone. The only person who has access to the data is the health officer or the safety officer of that company. If that one person who showed early signs of temperature, if a few days later he ends up being COVID positive, the health officer or the safety officer can go back 5 days, 10 days, 20 days, 40 days, and trace back who are the 400 people the person came across, and find out who are the 5 or 10 people who need to be taken out of the production line because they're more susceptible to get COVID, and therefore, as a result, protect the remaining 40,000 people on the production line. So as a result of that, we've been able to keep a lot of people safe across the factory. In some factories, they even wanted a contactless attendance system. So rather than using a pen or a thumbprint, what the application can do is generate a QR code, which you just basically slide or scan, and that gets captured into the backend application as an attendance system. But as a result, now a lot of companies are coming to us to also develop these technologies in a post-COVID world to drive productivity as well on a factory floor. Now, in some factories, cell phones are not allowed. And therefore, we were asked to come up with a third technology in situations where cell phones are not allowed. And this one's called Spot AI. So I don't know if you remember, I mentioned to you in the beginning that we have certain RTLS technologies. And therefore, what this RTLS technology is able to do is in real time, track any good, any box, any tooling, anything on a factory floor very, very quickly and digitize the whole production floor. And therefore, what we thought was if we can do that for boxes, why can't we do that for people? So we put that little chip in a wearable device. It's call it a little spot, like a little Fitbit or an ID card, so that when two people come within a certain distance, it sends out an alert. But the basic concept, what we're trying to do is create a holistic digitization approach, because the real value for companies is that if you can digitize your supply chain, your manufacturing, and your distribution across different factories, you're able to drive and see what productivity levels at any point in time across different factories is the way people are going to be looking at it going forward. And in addition, we applied the same technology, like I mentioned, to even do social distancing. But if you remember, we can not only do social distancing, but also do geofencing in chemical factories, in steel factories, to help people, warn people when they go into a certain zone that they're not supposed to go. And how do we do this? We put little tags. The tags could be these little, small little things that the size of a button, to slightly larger IoT devices that go onto your forklift, to go onto your AGVs, to go into your tooling, your work in progress material, so that on a production line, you can actually see how these things flow across production lines. And what do these tags do? They actually connect all these tags, send up the data to the locator. We push it out to our own proprietary edge software, which pushes it to the cloud, and then you're able to see the application to see how things move. And this is really transforming the way manufacturing is going to be done going forward, to be able to just digitize the whole production line to drive efficiencies across manufacturing. At the back end, this is what the application looks like. We can actually create three-dimensional pictures of a factory floor where you can actually see people walking around in real time. You can actually see the flow of material. And then you have a whole bunch of KPIs and applications that actually keep on giving you results. And we can actually customize these applications and algorithms based on what KPIs you want to drive across different production lines across the world. This is specifically on a warehouse, what we did, where we are tracking actually the movement of boxes on a warehouse as well. And we are able to reduce the time to find these goods much, much faster now than what existed in the past. So therefore, the real benefits of these technologies is really to drive asset management for machines and material, workforce management, are the people at the right place at the right time in a manufacturing process, how many visitors are visiting, how many subcontractors are on your factory floors, the time it takes for trucks to come in and go, for inventory management and for safety. So the applications are huge. But like I mentioned, in some factories, for the purpose of just COVID, they wanted just a quick, easy solution to use. So what we've done is, rather than provide the more holistic approach of using the whole RTS protocol, we're able to just provide these Fitbit-looking devices or a small little band or an ID card, so that when they come within a certain distance, it sends out an alert. And these technologies are being used in closed areas as well. In some of the five-star hotels, they're mixing and matching the use of camera technologies on the front end to make it less intrusive, and the back end for their staff to use the wearable devices as well. So what I want to do is just move on a little bit on two other applications that I thought I'd like to give you a little bit of a feel in terms of how these technologies actually work. The first one is healthy buildings. As we move along, what we're seeing is a number of companies are really more and more driving the use of healthy buildings and creating sustainability and measuring carbon footprint in buildings. And I think one of the ways that we can drive energy efficiency in buildings, factories all over the world is using IoT and AI. The world has already improved a lot in terms of LEED Platinum, in terms of ratings, etc. But one of the big areas that I think haven't been tapped yet is on the efficiency side. A lot of times, a lot of countries over the last many years have focused on the generation side, not on the consumption side. And I think that's where the big focus is going to be going forward. And the only way we can really drive it to the next level, beyond all the things we are doing today, in terms of using better material, in terms of architectural design, in terms of some cases using solar panels, is now creating a concept of connected buildings. And we are able to do that because, as I mentioned to you earlier, because of the significant decline in these sensor costs and IoT devices that give us that ability to create the concept of connected buildings. And really using that concept of connected buildings, really driving the ability to reduce the cost of energy, but also providing customers with a better experience in their buildings. And in terms of the better experience, it could mean air quality, it could mean occupancy detection, it could mean air conditioning. So how do we give customers who use buildings and office spaces a better environment to work going forward? And I think that's where the future is going to be going. And therefore, how do we really do this? We do this by putting these little sensors in all over the buildings, whether it is to drive the HVACs, the chillers, the lighting, to track the number of people, and analyzing all this data together, along with the extraneous data of the weather environment, to be able to drive this better experience in buildings. The other aspect that usually gets overlooked in driving this concept of healthy buildings is beyond the energy space. And therefore, what we've been thinking about and what we've been doing is looking at it from a more holistic perspective, also looking at it from water, air quality. In some buildings, they use gas to provide energy, so looking at the gas, electricity, and also in steam. And therefore, bringing all these parameters together is what's going to drive us to the next level in terms of creating the concept of net zero emissions or reducing carbon footprint and driving healthy buildings. And once again, we create applications like this. So this is the far right of that earlier slide you saw, that the customer sees a user-friendly application that looks like this, that just provides the insights. But what goes at the back are a large amount of connectivity, a large amount of deep learning, machine learning algorithms that calculates all this data and provide just the insight or an intelligence to the building manager or the plant manager who's managing the energy of a building in order to drive down costs. And the reason why this is very critical in buildings especially is that for some of the large building owners that own 50, 60 million square feet, in some cases 100 million square feet, the energy cost every year could be as high as anything between 500, 600 crores a year, or about 80 to $100 million a year. And therefore, if we can find ways to reduce that energy cost by 5 to 10% at least, that itself is anything between 30 to 60 crores of energy savings across a large portfolio of buildings. Now, there are a lot of challenges in terms of connectivity, in terms of making it all happen, but that's why I do feel that providing these services is the future in terms of driving energy efficiency and sustainability going forward. The one last application I'd like to share with you, and then I'll open it up to question and answers, is in terms of just improving machine performance and uptime. And the application in this case that I'll quickly share with you is in terms of wind turbines and solar farms. And the exciting part about this technology is the fact that it doesn't matter where in the world your wind farm or your solar farm, whether it's on a hilltop in Romania or in a hilltop somewhere in Italy or in Germany or France or in India, we have the ability to get that data to our control center in Bangalore and drive efficiencies to improve product output and also to reduce costs and downtime. Now, why is this really important? Because as all of us know on this call, the cost of energy generation in wind and solar has come down dramatically over the last 8 to 10 years. I remember the first solar project that I put up, my cost of tariff that I got was 18 rupees a kilowatt hour. Today, solar plants being put up in India are actually now trading and getting PPAs at anything between 2 rupees 36 to 2 rupees 50 to 2 rupees 80. So the cost of energy generation in solar and wind has gone from about 6 to 7 rupees down to about 250 to 3. As this has come down, the only way that we can drive productivity is reducing the cost of O&M is through really transforming it through digitalization to therefore reduce the cost of actual O&M and driving productivity. And therefore, what our ability to control all these assets all over the world from our control centers is where the future is. And the benefit for us, having collected 6-7 years of data from hundreds of wind turbines and solar farms all over the world, our machine learning algorithms have become really smart to be able to assess which turbine performs better under which wind conditions, which turbines perform better in such load conditions, which ones would fail when, why does some turbine fail more than some other turbine. And the same concept of machine health and predictive maintenance is used whether it is a CNC machine, whether it is a car, whether it is a large turbine, or whether it is a crane. The same similar concept is used to drive predictive maintenance down and drive efficiencies in plant performance. And we do this in the wind and solar farms through each of these individual algorithms. And like I mentioned, to create one of these algorithms can take anywhere between 4 or 5 months to 1 year to make one of these algorithms, to test it, refine it, keep on testing and refining it many times across many turbines, and then finally productionize it so that it's automated. And automation is going to be the key, because the game is not to have humans to keep on looking at all this data, is to have computers teach the computer the algorithm so that the computers can keep on analyzing the data and generating the insights. So it's a very automated process, because you want to take out the humans from this and make machines provide you these alerts so that us humans can start developing the next new generation algorithm to drive efficiencies and productivity and cost savings in manufacturing and to improve machine and turbine performance. So I just want to end by sharing a few final thoughts. One, AI is here and now. AI is used not only for long-term productivity in the long-term COVID situation, but in the near term, it is being used and will be used more to keep our workforce safe. It's going to really help us across different industries. It doesn't matter whether it's a factory, an office, a school, a university, a hospital. These technologies can be used across industries. Three, it's really going to change. COVID's going to change the way we interact, the way we work, the way we interact between people and machines. It's going to make a big difference. And I think these technologies are really going to make a difference in the way we drive productivity in a very, very different industrial world going forward. So with that, Shreya, I'm going to end out there. And what I'm going to do is open up to any question and answers that people have, and I'd be happy to answer them. So over to you, Shreya.
Thank you, sir. You've generated quite the buzz. We have a lot of questions pouring in. And I wanted to know, how would you like to go with it? Would you like to go one by one, or would you like to take a bunch of questions together?
Shreya, I'll leave it to you. You want to ask me a couple of questions? I'm okay either way.
All right, so we'll go one by one then, just so that. So the first question is from Himanshu Sharma, who asks how predictions are done, how predictions about electrical signals are done.
Yeah, no, great question. So what, in a very quick way, what we're really doing is reading electrical signatures. So when you look at voltage, you look at amperes, and you look at these electrical signals that are coming out of machines, what we're really doing is using AI to read the electrical signals to detect certain patterns that are being generated to be able to make these predictions happen.
Okay, sir. So the Marva asks, are the sensors capable of withstanding temperature as high as 850 degrees in the case of aluminium melting or holding furnaces?
Yeah, great question. It's amazing because we've had a lot of requests from people in the steel industry, aluminum industry, for exactly that, to find certain sensors to actually withstand that very, very high kinds of temperatures. So in fact, we are currently doing a project and some testing to exactly find these sensors to manage and cope with very, very high temperatures. So what I would just request him is that if there's some way, Shreya, that you can connect with him or figure out a way to connect with us, we'll find a way to share with him what we're doing exactly on this, because we're hearing a lot of these questions, especially for speedoing, for the torpedoing issue in a steel plant, and that's something we're working on right now. So I'm hoping that we'll have a solution very soon, but I'd love to connect with this person and share with him what we are doing.
Definitely, sir. So Vimal Kumar Eswarlal has a question saying, wonderful presentation, sir. How AI can be used in solar industry?
Absolutely. So one of the big challenges in solar we've seen is that, you know, people normally think that obviously wind turbines are far more complicated because it's got a lot of moving parts, it's got a lot of machines, whereas the solar industry does not have that level of complexity that a wind turbine is. However, as I was sharing, as the cost of solar has gone down from 18 rupees a kilowatt about 9-10 years ago down to 2 rupees 40, the pressure on all of us in the industry to drive returns when your revenue is so small has also gone up a lot. And therefore, what we've been doing is using the power of AI to track different parameters in the solar: inverters, panels, cabling, junction boxes. What we do is collect all that data. But what's been fascinating is the performance of solar farms in India is very, very different from Europe because weather conditions are different. In Indian conditions, which are very high, hot conditions, high humidity, the failures we see in India for inverters are very different from what we're seeing in Europe, number one. Number two, dust conditions and soiling patterns. In fact, we've just patented a soiling pattern algorithm. So therefore, what we are finding, Shreya, is this. When you have a 100 megawatt wind farm, solar farm, that is across 400 to 500 acres of land. Now, it's physically not possible for us to have enough people on site to go across 500 acres to clean them. So what are we doing? Using our algorithms, as we keep on detecting all these data coming in from these solar farms, our algorithms are able to provide intelligence to the site manager or plant manager at the solar farm to tell him which string to clean on which day. So we tell him, okay, today go on these 5, tomorrow go on these 5, and day after go on these 5, and therefore use optimally how to clean these solar farms. So we are seeing a lot of different kinds of challenges in solar farms, inverter failures, inverter productivity, solar degradation, panel degradation. So using all this intelligence, we're able to use all our algorithms to improve generation in solar plants.
Thank you, sir. Sir, the next question is, how do we integrate IoT and AI for tire manufacturing?
Wow, I wonder whether these folks have seen the presentation before. We recently did one case study, one use case for the curing process in the tire industry. Let me just share this one small, let me do a slide size, come back on the tire industry specifically. At the end of the day, we are data scientists and AI folks. We don't know enough about every industry in the world. That is what the company knows because they've been making steel for 20 years, 30 years, 40 years, or making tires for 40, 50 years. But what we find is there are a lot of challenges that we come across in different industries that haven't been able to be solved. And therefore, it's been a fascinating collaboration between industry and data scientists to come together for the first time to solve these kinds of challenges. And what I tell everybody is that even we won't get it right the first time because this world of Industry 4.0 is still very relatively new. And therefore, what we find is we do a small little case study or a pilot or a test. We will fail, right? We will fail a few times, which means we might need to change some sensors. We might need to change the algorithm. We might need to change the way we analyze the data, but eventually we do get it right. Once you get it right, then you scale, right? And that's the way I tell everybody. The other big challenge I see in this whole world, Shreya, is returns. one of the biggest questions CEOs ask me is like, "TP, how do we know if we spend 100 rupees that we're going to get a return on our investment?" And that's why I tell CEOs it is very difficult, because a lot of times, even we have not solved every problem in the world, and there are always new challenges coming up. And therefore, I feel that when you enter these the world of AI, sometimes it's tough to predict what the return is going to be. And that's when I tell people, whether it's to figure out how do you improve the yield on certain molecules in a chemical plant, or how do you improve the productivity in an oil and gas plant, or in how to make soaps. I don't have all the answers on day one of what the returns will be or what the return on investment is going to be, but we will figure it out and we will succeed. We might fail along the way. Coming back to the question in the tire industry, one of the biggest one challenge that we did come across in the tire industry was in the curing process. And what we found was, and if I remember right, was that there was a failure because of a 4 millimeter offset was creating a bit of a problem. And therefore, what we were able to do was use certain sensors and algorithms to be able to actually minimize or remove that failure that was happening in that offset, to reduce the wastage in the curing process. So that was one example in the tire industry. But I'll be happy to share lots of other case studies that we're also learning as we go along in terms of how we've applied this in the tire industry.
Definitely. I think, sir, your answer has covered a lot of other questions, which were plenty on rate of return on interest and how the adoption basically will fold across the industry. And like you've mentioned, that it's a step-by-step process and it comes as it will. The next question is from Amit Maheshwari. He said that, is your Spot AI social distancing and contact tracing accurate to centimeters like the ultra wideband technology?
Yeah, great. It's a great question. So in the world of IoT and sensors, you have a wide variance of protocols, right? And obviously some of these technologies are still cutting edge and new and therefore more expensive. Some of the technologies are more now, and protocols are more mass scale and therefore cheaper, right? And therefore in the world of IoT, you have the whole breadth of it. So think of it, the analogy I would give everybody is 2G, 3G, 4G, etc. So when 2G came up, when it came out first, it was very expensive, and over time it's become very low. Same with 3G, same with 4G. Today 4G is, all of us are making calls for pesos on a minute, what may have cost us a few rupees a minute some years ago. So like that, in the world of IoT and Industry 4.0, sensor protocols have also, they're developing every day new things are coming out. And therefore newer technologies are always more expensive. So to the specific question that I was asked about UWB, so there are many technologies and different applications for different technologies. You have LoRa that really helps you for outdoor applications. So for example, if you're on a port, in a port situation, we have a certain Fitbit or like a watch that if I fall into the water, it immediately sends out an alert to the safety officer that there's a man overboard or I've fallen into the water, so somebody can save me. Now that uses a certain protocol, and therefore you have things like UWB, which is very precise, which is one of the most precise technologies and accurate technologies in a big factory. But the challenge with UWB is it's really expensive, right? And these are some of the cutting edge, these are some of the technologies being used in Europe at some of the leading automakers in Europe, and I know a couple of them that are using UWB today. But the challenge is that, and we work with all these partners who make all these technologies, and we work with them because they provide us the hardware, we do all the software and the intelligence and the AI. We don't make the IoT devices, so we get these IoT sensors, etc. on UWB. But I've just found that it is so expensive, and given the frugal nature of manufacturing in our country, I just don't think we can afford UWB technologies today. However, there are other technologies that exist like BLE and many RFIDs and barcode, other technologies that can actually are much cheaper. And the question goes back, Shreya, what you want to achieve. If you want to find a tooling down to 10 centimeters, then you go for one technology. If you tell me, TP, I don't need 10 centimeters, I can do it between 30 to 50 centimeters, then you use a second technology. So that's what's happening around the world, is that based on what the customer wants to do in terms of his budget, based on what the application want to do, and therefore we would adapt its sensors based on what the output is. So that's what UWB, how UWB is, based on the stack of technologies and protocols that exist around the world.
All right. So I hope that answers your question. Another question, so a very different question actually, from Divyata Ashia, who asked that what pushback, if any, have you experienced regarding privacy concerns? Example around proximity tracing, as you look to expand beyond factory floors and corporate environments, and how are you managing this?
Yeah, no, sure, great question. One of the biggest problems is privacy, and this was something we really we spent hours and hours of time talking to some of the lawyers in New York and London for some of the biggest companies in the world, and we debated this. And there is no right answer, Shreya. There is, because we're all entering a new world where there are no rules. You know, nobody's told us that this is the rules for privacy, because what the rules for privacy were yesterday are very different today, and it's going to be different tomorrow. So I think to some extent, you know, one of the things I did think, Shreya, before was I'd give this technology for free to the world. That's what I thought. You know, this Pro technology, I really, really want to protect lives. I want to save people. I want to keep people well. So why don't I give it for free? But one of the reasons why I didn't give it for free was because of privacy concerns. Was that I don't know what that right answer is, and I just don't want to get into this debate about where do you draw the line. So that's why we limited our technology to use in offices and enterprises. We're talking to schools and universities now, and therefore adapting the technology based on the privacy guidelines that that particular company wants to do. But to be more specific, Shreya, let me just say 3 or 4 specific things we did to address the privacy issue. The first one, in Trust AI on the camera feed, we don't keep any recording on our servers, right? All the storage of the data of camera feed is kept on the company's own server, what they call DVR, NVR. So we don't store any data, number one. Number two, our edge box only analyzes the feed. So it's like a brain. All it does is processes all these cameras feed coming in very, very quickly in milliseconds and sending out an alert, right? So we don't really keep that data. We're just keeping it to analyze it and send it back. The third thing we do is the alerts that are sent out, we can either keep it on the cloud, but for some companies that have privacy concerns, for example, sometimes some governments come to us and say, you know what, TP, we want to keep it on our, or we don't want to send it even to the cloud, then we can do it completely on premise. So we put our software on the servers of the company within the 4 walls of the factory, so nothing goes out. So therefore, we've adapted it specifically on the camera feed. On the Pro application, we did a number of things there. One, we don't want to track and locate where you go outside the factory. So that's one thing we are not doing, nor do we want to do that, right? And Shreya, that goes back to what you were saying for the public versus private. So we don't want to know where you go outside. That's up to you. All we are doing is keeping the person safe within the factory walls. Two, even within the factory, if both of us work at whichever company, GE or Siemens or whatever, I won't know you, you won't know me. I will show up as an encrypted code on your phone. You will show up as an encrypted code on my phone. We are completely anonymous. Like I said, with these companies, the only person who has access is the safety officer, because everybody knows him, he knows everybody, or the health officer, or an HR administrator that the company chooses. That is it, right? So that's sort of how we adjusted the privacy concerns. However, every company has a little bit of a different. Some companies came to us, some of the largest pharmaceutical companies in the world said, we've got 5,000 or 10,000 salespeople who go around the country every day. How do we keep their customers know that they are safe and COVID-free? Now, we can track them. We have technology to actually see how these people move around and where they are and track what their temperature is. But I tell all my customers, you tell me where that privacy boundary is, and we build the technology for what you want. If you want to give us the ability to track 10,000 people in your sales force as they move around the country, we'll do it for you, right? If that helps you from a productivity and a COVID perspective. So I think, Shreya, at this point in time, I'm leaving it to customers and companies to define that boundary box rather than us taking that upon ourselves.
So unfortunately, we have run out of time and it's bang 12:30 right now. And we have a lot more questions for you. I can assure you that it's like just the numbers are going up. But I'd like to tell our participants that thank you for sending in your questions. And as much as if Sir likes, we'll be able to connect you with him and you could direct your questions to him and get your answers. But Sir, I'd like to thank you so very much for taking our time and giving this wonderful presentation. And you have really given a wonderful insight into a world that people are still trying to understand and explore, and especially non-tech sectors benefit a lot from presentations like this and get an insight into what it is like to enter an AI digital world in the 21st century. So thank you very much, and I hope you had fun as much as we did listening to you.
No, thanks so much, Shreya. For me, I hope we can all work together to keep everybody safe and protect everybody and make sure that we in India and all over the world, industry comes back to normalcy. So I just hope everybody stays safe and healthy in these difficult times. So thanks so much, Shreya. See you then.
Thank you.
Bye.